Hello everyone, welcome back to the channel Code with AKJ. Today is day 52 of solving LeetCode Certified Challenge, and today we are going to solve the last problem from the priority queue section, which is total cost to hire K workers. So before we start, make sure to like this video, share it with your friends and comment your thoughts below, and also subscribe to the channel for the latest updates. So let's get started with our problem statement. So you are given a zero indexed integer array costs where cost of I is cost of hiring the ith worker. You're also given two integers k and candidates. We want to hire exactly k workers according to the following rules. And the rules are you will run k sessions and hire exactly one worker in each session. So in each hiring session, we'll choose the worker and the lowest cost from either the first candidate workers or the last candidate's workers. Break the tie by the smallest index. So here we have given an example. And finally, if there are fewer than candidates workers remaining, choose the worker with the lowest cost among them. Break the tie by the smallest index. A worker can only be chosen once, and we need to return the total cost to hire exactly k workers. So since it's a pretty big problem statement, so let's try to understand what the problem statement actually is. So we are given an array cost where each element represents the cost to hire a worker. And we are also given two integers k and candidates. So we need to hire exactly k workers following this process. So the process is, so in each hiring session, we can look at either the first candidate's workers or the last candidate workers. So we pick the worker with the lowest cost among them. If there's a tie, we'll choose the one with the smaller index. So once a worker is hired, they are removed and cannot be hired again. So this is all about the problem statement. So let's understand this problem statement with this given example. So here I have written the first example. Here I have mentioned the cost array and the k values, which means we'll have to conduct 3 hiring sessions and we need to select 3 workers, and the candidates group would be 4. So since we need 3 workers, we'll start by grouping the candidates from the first and also from the last. We'll have 3 sessions and we'll hire the worker who has lowest cost, and if the costs are same, then we'll pick based on the smaller index. So this is all about the problem statement. So let's look at our first example. So we'll group the first 4 candidates here, 17 to 2, and the last 4 candidates, which is 2 to 8. We'll find the lowest cost worker from both the groups. So here from the first group, we can see that the worker with cost 2 is present at index 3. And in the second group of candidates, we can see that there is also a worker with the cost 2. So here, since the cost here are same, we'll compare the index. And since the index 3 is smaller than the index 5, we'll choose this particular worker in this case. So in our first session, we have picked this particular worker whose cost is 2, which is present at index 3. So currently our cost would be 2. So after hiring this particular worker, we'll remove this from the array. So after removing this 2, our array would not contain this value 2. So again in our second session, we need one more worker to hire. So again we'll group this whole array from first 4 and the last 4. So the first 4 values would be 17, 12, 10 and 7, and the last 4 would be 2, 11, 20 and 8. So again we'll compare the workers who has lower cost. So in the first 4 candidates, the lowest cost is 7, and the second group of candidates has the cost 2. So since 2 is the lowest cost, we'll hire this particular worker from the second group of candidates. So our total cost would be 2 plus 2, which is 4. In our final session, the first 4 would be 17, 12, 10 and 7, and the last 4 group would be again this 7, 11, 20 and 8. Here we can see that the 7 is present in both of the group. So since they share the same cost as well as the index, we'll hire this worker which has the lowest cost in the first group as well and the lowest cost in the second group as well. So the cost for this particular session would be 7. So since we need to return the total cost to hire the k workers, the total cost here would be 11. So for this given example, our answer would be 11. In the same way, the example 2 works, where we need to hire 3 workers and the group of candidates here would be 3. So we'll run 3 sessions, and we can see here that the total cost to hire these k workers in this cost array would be 4. The explanation is given here, where in the first hiring session, the lowest cost is 1, and in the second hiring session, the lowest cost is also 1, and in the final hiring session, the lowest cost is 2. So the total cost here would be 4. So I hope the problem statement is clear. So let's start with our brute force approach, which is the most direct approach. In our brute force approach, the first step here would be to take the first candidates and the last candidates. And our second step here would be to choose the smallest one in each of the group, that is by sorting these two groups. So we'll sort the first candidates and we'll sort the last candidate groups. And after sorting it, we'll find the smallest minimum element which would be present at the first index of these two groups. We'll compare both the values and choose the smallest one. And finally, after choosing that particular value, we'll remove it from our array. Again, we'll follow this process until or unless we'll hire k workers. So we'll use a for loop which would run k times, and inside our for loop we'll perform these operations where we will group these candidates based on our candidate value, and we will sort both the groups. We'll find the smallest element out of both the groups. We'll compare and we'll remove this value from our array. After each session, we'll get a value and we'll add this value to our cost variable, which would give us the total cost to hire k workers. And then we'll return this cost variable at the end of our code. So this is all about our brute force approach. So let's quickly code our brute force approach and let's submit. So here's the code for our brute force approach. So here, instead of creating two different groups, that is from first candidates and the last candidates, and sorting them and comparing their values and adding it to our total cost, what I've done here is to store all those values and inserting it inside our available vector. So here I'm pairing those cost value as well as its index inside our available vector. I'm pushing all the values, that is starting from 0 to candidate value, and again from n minus candidates to n value. So instead of creating two different vectors, I tried to push all these values inside a single available vector. So after pushing these values, I'll sort this available vector, and finally after sorting it, the smallest value would be present at the starting index. So we'll take that index by using available of 0.second, and we'll grab that cost value by accessing it with available of 0.first and adding it into our total cost. So in this way, I've taken both the index value and the cost value here, and finally with the help of our index value, we'll remove that particular selected worker from our cost vector by erasing it from our cost vector. So after performing these steps k times, we'll return the total cost, which would give us the total cost to hire exactly k workers. So let's quickly run this code. It's okay, so let's submit. As you can see, this approach gives us time limit exceeded because of its high time complexity. So let's try to analyze the time complexity of this solution. So here each hiring round sorts up to 2 cross candidates elements, that is O of C log C. And we do this k times, so the time complexity becomes O of k cross C log C. So removing from vector make it worse, which generally takes O of n square in worst case. So overall time complexity of this approach would be O of n square. And coming to the space complexity, the space complexity here would be O of candidates for storing the candidates inside our available vector. So the time complexity here is O of n square, and the space complexity here is O of candidates, which is highly inefficient for the larger values of cost vector, hence it gave time limit exceeded. So let's try to solve this problem statement in a better way, which will be discussed in our optimal approach. So now let's move on to our optimal approach. So here, instead of rebuilding and sorting in every round, we'll use two min heaps to find out our minimum value out of both the groups. So the idea here is to use two priority queues, that is two min heaps, to store potential candidates. We'll keep two pointers, left starting from the front and right starting from the end, and we'll always pick the smallest cost from the two heaps, and after hiring a worker, we'll push the next available worker from that side into the heap. So let's do a quick dry run to understand how our optimal approach works. So here I have written the first example where we need to hire 3 workers, and we can group at most 4 candidates here, taken 2 different heaps, and we'll also use 2 different pointers. One is the left pointer, another is the right pointer. Left pointer starts from the front and right pointer starts from the end. So our first iteration here would be that the left heap contains values 17, 12, 10 and 2. And the right heap contains values 2, 11, 20 and 8. So in the round 1 or the session 1, we'll have the value 2 from the left heap, and we'll also have the same value 2 from the right heap. But if the values become same, then we'll consider the value with least index. So since the left pointer value starts from the start, hence the index values will also be smaller than the values present in the right heap. So we'll consider this particular 2 in this particular round 1, and our current cost would be 2. And after hiring this particular worker, we'll remove this from the heap and we'll push the next value with the help of the left pointer in this left min heap. So after the first round, the values in the heap would be 17, 12, 10, and since 2 is removed, we'll take the next value, that is 7, and we'll push that inside our heap. So the next element inside our min heap would be 7. The right heap values would be same, that is 2, 11, 20, and 8. So again in the second round, we'll take the smallest values out of these two min heaps. So here the smallest value is 7, and here the smallest value is 2, and we'll consider the smallest value here, that is 2. So we'll hide this particular worker and we'll remove this from the right heap, and we'll push the next element from the array inside this right heap with the help of our right pointer. Now the cost here would be 4. Our main heap contains values 17, 12, 10, and 7, 11, 20, and 8 in the right heap. So in the third round, again we'll find the smallest values out of these two different heaps. So here the smallest value is 7 in the left heap and the 7 in the right heap as well. So since the values are same and the index values are also same, we'll consider this particular worker to get hired. So we'll remove these values from both the heaps, and the cost here would be 7. So we have performed 3 different sessions to hire 3 workers, and so after performing these sessions and hiring 3 workers, our total cost here would be 4 plus 7, that is 11. So let's quickly go through the time and space complexity of this approach. So generally each push or pop on heap data structure takes O of log k time complexity. So here k is nothing but the number of candidates we are pushing inside the heap. So at most k candidates would be present inside our heap. So the time complexity of each push or pop operation would take O of log candidates time complexity. So the overall time complexity of this approach here would be O of n plus k log candidates. So generally we are performing these operations till we get the k workers. So hence the overall time complexity of this approach would be O of n plus k log c. And coming to the space complexity, the space complexity here would be O of candidates for both heaps combined, which is super efficient and works perfectly for larger inputs as well. So the space complexity here would be O of c, where c is number of candidates. So this is what time and space complexity of our optimal approach is. So let's quickly go through the code and let's submit. So here's the code for our optimal approach, where we are using priority queue data structure to get our smallest cost worker. So the code starts with taking the size of our cost array and also the total variable, which would be long and initially 0. We'll use 2 in heaps, that is left heap and right heap. We'll also take 2 pointers, left pointer and right pointer. Left pointer starts from 0 and right pointer starts from the end, n-1. So initially we'll fill the candidates for the first round, that is we'll run from the start and we'll push all the elements inside our left heap, and we'll start from the end and we'll push all the elements in the right heap with the help of our 2 pointers left and right. And after filling the initial candidates into our respective heaps, we'll gather the topmost element from both the heaps with the help of top function. So we'll first check whether both heaps are empty or not. So if they are empty, then we'll return int max, and if they are not empty, then we'll grab the topmost element of both the heaps, and we'll compare values of both the heap. So if the left main value is less than or equal to right main value, we'll consider the left main values and we'll push it into the total variable. And after considering that particular worker, we'll remove the worker from the left heap with the help of pop function, and again we'll push the next element from the start inside our left heap with the help of our left pointer. And if the left mean value is greater than the right mean, which means the smallest cost of the worker is in the right side of our heap, then we'll consider the right mean value inside our total cost. We'll pop that worker from our right heap with the help of pop function, and we'll push another worker inside our right heap with the help of our right pointer. And finally, after performing these operations k times, we'll get our total cost to hire exactly k workers, which would be stored in our total variable, and we'll return that total variable. So this is how our optimal approach works. So the time complexity here would be O of n plus k log candidates, and the space complexity here is O of candidates. So let's quickly run this code. It's working, so let's submit. As you can see, this approach gives a successful submission. So let's quickly move on to a time and space complexity analysis. So in our brute force approach, what we were trying to do is to store the cost of the worker as well as the index and store in a separate vector. We were trying to sort the group in each hiring session, calculating the total cost, which generally took O of n square time complexity and O of C space complexity, where C is the number of candidates. So generally this approach was very slow for large input values. So hence we have optimized our approach by using the data structure priority queue. Here in our case we have used min heap. So we have maintained two different min heaps, one from the left and one from the right, and we were trying to grab the topmost value of both these heaps, and we were comparing both the values and we were calculating the cost. So this was our optimal approach. So with using this optimal approach, we have reduced the time complexity from O of n square to O of n plus k log C, where C is the number of candidates, whereas the space complexity remained same, which is O of C. So generally this reduction of time complexity worked for us, which is super efficient for larger inputs as well. So in this way, we have optimized our time complexity with the help of priority queue approach. And that's how you solve total cost to hire k workers efficiently using two heaps. So if you found this explanation helpful, don't forget to like, share and comment below. And of course, subscribe to the channel for daily LeetCode solutions. So until then, keep learning, keep coding. Thank you.